Hello, I hope everyone is doing good. Let's start with the next session in the distributed systems. Today we are going to discuss about three important topics. The topics are architecture styles, middleware in the distributed systems, and self-management. So while we are discussing about this, in between we have a small topic called interceptors. This is a small topic just as a definition part, and we need it while we are calling a number of procedures in between. Now, let us move with the first topic, that is architectural styles. There are four types actually. The four types are layered, object-based, data-centered, and event-based. So coming to the first topic, that is a layered architecture. In layered architecture, we are going to follow up with the OSI model. So where we'll be having 7 layers starting from physical layer and ending with the application layer. Now, when we are having layers components in our distributed environment, when there is a interaction which is of the sequential type, then we have to move on with the layered architecture. Now, in the layered architecture, when the request is started, then the flow will be from top to bottom, because when the request is generated, when the request is about to initiated, that will be done at the application end. Thus, the application layer will be activated from there to the physical layer. And in terms of response, it will be from bottom to up, that is from the last layer, the physical layer, to the application layer. So this is the environment where we are going to have n number of layered structures within the flow of the request and response manner. Now, when we are discussing about the object-based architecture, it is in the procedure of the objects interaction. So objects can be interacted with each other in the given interface. Now, how it is possible? There is one implementation procedure, that is RPC. RPC is nothing but remote procedural call. So in the remote procedural call, every procedure will be called from one system in the distributed environment. So wherever this procedure which I have called from my system, that procedure will be activated in the distributed environment, and the task of that procedure can be accessed to my system. So this is what the RPC procedure is. There we will be having the client and server environment, because the client who is calling the procedure and the procedure which is giving the functionality will be called as a server stub over there. So these two will be interacted. Now, in this object environment, all the objects will be directly connected with this RPC combination. Now, when we are entering to the third topic, I mean the third type, architectural type, style 3 is of the data center type. So in the data center type, the direct communication will be done with the database. So here the data space which is there will be shared between n number of components. See, when there is a centralized database which is available, all the components are communicated to this database to get the data, to add the data, or is to delete, modify. So n number of operations may be taken place. So the data is centered over there, and that must be shared between n number of components. So this type of environment is called as data-centered architecture. The fourth one and the last type in the architecture style is the event-based one. See, this is a thing when triggering happens. See, when we click something, immediately its trigger happens and an event to be taken place, right? So in the similar way, when a component activates something, immediately the other component which is related or interacted must be generated with the event output, right? So when an event occurs, immediately that event to be notified to all the components, and its result also to be notified to the respective system component which has generated this event. So this is what the event-based architecture is. And the next topic in today's session is the middleware. See, coming to the middleware is just a software which will be an interface or is an intermediate between the lower level, that is the operating system and the application. In between, we will be having this middleware. The importance of middleware is it will be provided with a number of services. These services will be like, which will be making an application independent to the platform or its language or else the operating system itself, the hardware. Right. So middleware responsibility is to make our application to work anywhere in the distributed environment without breaking the flow of the executions or the accessing points. So this middleware must lie between the application and the operating system. The services which it can provide are, it can make the applications platform independent, hardware independent, language independent, and the network independent. The examples for this, I mean, the how a middleware can be implemented will be with the four parts. Those are RPC, RMI, CORBA, COM. See, RPC is nothing but remote procedural call, where we can call any procedure from one system in the distributed environment, and we can get the output of that procedure with one call. Remote method invocation is nothing but this will be totally in combination with the object-oriented systems. So one object, the other object. So these two objects can be invoked with the methods when they are in access with the particular functionality. So I can call any method from my system in the distributed environment, and I can invoke the operations. I can access that particular method whenever I want. Next one is CORBA. See, CORBA is nothing but Common Object Request Broker Architecture. So this is nothing but all the components will be accepted in with response, with request, and acting as one of the intermediate combination to all the remaining architectures. So this is commonly available to all the resources which are available in the distributed environment. COM is nothing but Component Object Model. So this model will be a software where it can be applicable, it can be activated or it can be executed anywhere in the distributed environment. And DCOM is nothing but the distributed COM. So these are some of the examples how a middleware can be implemented, and these are the services: platform independent, hardware independent, language independent, and network independent are the services of middleware. Now coming to the next topic, that is the interceptor. See, interceptor in distributed system is nothing but a software which can break the flow of your execution. See, whenever we have RPCs, RMIs in our network combinations, when a code is executed in a flow, somewhere we have called with some procedure or is an object which has to be executed on priority. So, and then and there itself, our execution flow must be broken. So this is nothing but the intercepted call. So here the interceptors will be activated to break the flow of our execution for some time. And we will be in combination with the flow of the call. And then after that, we will be back to our existing environment. So that is the job of the interceptor. And the last topic in today's session is the self-management. See, coming to self-management, in the distributed environment, all the systems must be able to adopt all the changes which are happening in the network, right? So if one system has got a lot of load, then and there itself, it has to be killing some processes and making itself idle for some time to back up its data and so on, so right? So for this kind of things, all the systems in the distributed environment must be self-management. So in the self-management, we have 4 steps, that is configure. They have to configure them by themselves when a new network comes. Self-managing, so whatever happenings, recovery procedures and all, healing procedure, optimization, if our code is very lengthy and if we want our data to be only 1,000 lines of code, then immediately we have to make our system to be optimized itself. The best example for the self-management system is a feedback control system where we can adjust with our accuracies with the machine learning concept. Here we are going to take one example of this as a feedback control system. The initial configurations are initialized at the first step. Then if we need any adjustments in between, we are going to accept all those, and we have to control the noises, we have to control the disturbances, whatever we are getting in between. And with this metric combinations, the output has to be taken and it has to be analyzed properly, and we have to provide the output in a proper way. Right. So in the self-management, we can take IoT devices as the best examples where they can set themselves with few sensors kind of thing. So nowadays we have many technologies with AI also. So all this comes under self-management. So this is the end of this session. If you have any doubts, please be free to contact through comments or directly in the college. Thank you.